Thank you very much. Thanks for having me. My name is Sitnik, and today I will speak about state of the .NET performance. But why am I speaking about the .NET performance? I'm one of the authors of a very popular library called benchmark.net. It's the most popular right now for benchmarking .NET code. I also maintain the awesome .NET performance list, and I contribute to virtual machine of .NET and some other repositories. So, and at work, I developed system for trading energy, and it also has to be fast, and we do it with .NET Core, and we are running in production with .NET Core since July 2016. So it works. So, to show you how performance affects the end user, I'm going to start with a short video. This is a footage from a game. Gate is called Age of Ascent. And my question to you is, what have just happened? Louder. Yes, garbage collection. So, we need to understand what .NET Core is. .NET Core is a fork of desktop.NET. It has a lot of improvements, but the JIT itself and the garbage collection algorithms are more or less the same. So we don't have like conceptual changes. But we have a lot of new things that we can use to get better performance. And all of the things that I'm going to talk about today, they answer one question: how to get the best of GC. So first of all, as pointed to me by Jan Kotas, who is a core engineer at CLR, we should use the right GC mode. So the demo, we could see pause for like a few seconds. It was because it was configured to run in workstation mode, not in the server mode. And in the server mode, we have 2 threads per each logical core. In workstation mode, we have only 2 in total for the GC. So first of all, we choose the server mode. Second of all, we can reduce the allocations. And third of all, we can get rid of managed allocations. And how can we do that? We either use value types, we can pull the managed memory, or we can use the unmanaged memory. And these are the things that I'm going to talk about today. So first of all, new feature of C#7 language, value tuples. So who has ever used tuples? Item 1, item 2? Great. So with C#7, we no longer need to create new type whenever we want to return more than one thing from a method. And the value tuple is value type. This is why I'm talking about here today. And if you have been to Dina's talk, you should know that value types have better performance characteristics. And when I speak value types from the C# perspective, I mean structs. So they have better data locality because they don't have any extra fields. So they are very close to each other in memory, and also they don't add any pressure for the garbage collector because they are just values. Garbage collector is not managing them, it doesn't see them as references. But they have some disadvantages. First of all, as shown by Dina, we can easily get to boxing. Then they are by default sent to methods and returned by copy. And it's not obvious when this copying happens. And first example is following. We have very simple structure with single read-only field and constructor, of course. And we have this ugly method, which is using this keyword to change the value. And my question to you is, what's happening in this example? So we initialize it with value of 1, we print it, then we call the ugly method and we print it again. So how do you think? What is the result? I can hear 1. Okay, so it's 1 and 2. Because by using this keyword, the structure can override its own value, even if it's read-only field. And this is why, when we apply the read-only field, C# compiler wants to make sure that it's immutable. So before calling methods like this, or a method that could potentially use this keyword, it's creating a defensive copy every time. So with read-only, we get following result. And I'm not sure if you follow John's Kid blog, but he was writing about this problem some time ago. And this is why if you take a look at the NoDaTime library, all of the public fields of the structures are not read-only, just to avoid this problem. But with C# 7.2, we have a possibility to mark a whole type as a read-only. And then simply this for the structures is read-only reference, so we cannot change it. So I know that nobody is using this keyword to change the value, but because of this, there was always this copy. So this is the first feature that we get, to make value types more attractive. Second of all, previously we could only get a reference to a field and send reference to a method. With C# 7, we can also return references and create local references. So we still use the ref keyword, and to create a local reference, we do something like this. But here my first recommendation, please don't overuse this feature. As you can see, the code gets complicated. We should use it only when we measure that it will be beneficial to use references. And let's take a look at a benchmark. We have a list, an array of large structures, 5 fields, 5 integers, and we will initialize the array. So when we do it by copy, we copy the value from the array to local variable, then we initialize it, and then we copy it once again to the array. So every iteration of a loop, 2 copies made. With local references, we just create a local reference to a place in a memory. It's an alias. So we don't copy any memory. We just work with references, something we used to do in C++. So how do you think what's the difference can be? Like 10%, 20, 100? Yeah, so in my example, doing this by references was more than 4 times faster. And the low bar is doing this by reference, and the big bars are doing this by value. And as you can see on the right, we have different JITs, legacy JIT and REU JIT. And how is it possible that this new feature of C# language can work with the old JITs that weren't modified for the last 5 years? So this feature is based on a feature of CLR that was there since the early beginning. It's called managed references. So C# just wasn't exposing it so far. So you can use it today and deploy it to some old virtual machine which your customer is using and not willing to update, and everything is going to work fine. But as you know, we could previously, and we can still, use unsafe in C#. So who has ever used unsafe? Yeah, few people. So we deal like with row pointers in C++. But we have to pin the objects in memory to prevent the garbage collector from moving them. So let's compare the old way, the unsafe one, with the new managed references. So in my benchmarks, it turned out that the new way is faster for small amounts of memory because we don't have to pin the memory now. Because the managed references are understood by garbage collector, so we don't need to pin things in memory. And do you know if unsafe code has any limitations? Have you faced any of them? So, when we use term managed code for .NET, we very often tend to forget that .NET offers us type and memory safety. And one way of doing this is that .NET has a tool called IAL verifier, and before executing our code for the first time, it validates the code. It makes sure that we didn't make any huge mistake and that we are still safe with the memory. So it, for example, it prevents the dangling pointers and all of the nasty old bugs that we could have in C++. But when we go unsafe, the IAL verifier does not verify this part of the code. And this is why, to execute part of an unsafe code, you need a full trust. And we as developers very often tend to forget about this because each of us is administrator on our local machine. But I remember when a few years ago my demo on Azure has failed because by default they weren't allowing the unsafe code to be executed. And this is why if you take a look at GIL or any other popular high-performance .NET library, they are not using unsafe because some of us could use it in limited trust environment. So this is why you should use the new managed references because they don't have limitations and they are just faster. As of today, there is no book that describes the references, all of the new stuff from C#, but the guy that is implementing these features, which is Vladimir Sadov, has recently started blogging, and I really recommend you to read his blog because he explains what kind of problems these features are solving, what are the limitations, and you will just know everything is possible about current features. So, please remember to use value types for better data locality and for not introducing any pressure for the garbage collector. Use managed references to get rid of unsafe and use read-only types to prevent from copying. So, the next scenario is not trivial. So, as you know, task is a reference type. So each time we return task, we allocate something on the heap. But one of the scenarios that was profiled and turned out to be common enough to make it something new to change it is following. We have a method which is executed very, very often. It's allocating task. But in that case, most of the time it could be executed in synchronous way. Think of reading data from a network stream by some JSON deserializer, let's say. You would like to read asynchronously, but the network stream downloads the data from time to time. So most of the time, the data is already present in the stream, and you can read it in a synchronous way. And sometimes it's downloading another chunks of memory. So we don't need to always allocate the task. And this is the problem that is solved by value task. So value task is a new type. It's not a replacement for task. It's supposed to help in this single scenario. So when we can't execute in synchronous way, we call the method which returns the result, and we wrap the result in a value task. If it's not possible, it's not our hot path, we do the old way. So we start the asynchronous task and just wrap it into value task. Okay, as simple as it gets. But with async await, we cannot get the benefits of inlining because the method gets big, it has some try-catch internally, but with value task, we can inline the methods because we don't introduce anything that could prevent from inlining. So if we apply this attribute, we can inline the method. So how to consume value task? Unfortunately, it's not only about async await, because the async await pattern was designed for the other scenario, the most common, like we have to await something. But here in our case, the result is almost always ready, waiting for us. But you need to know how async await works. So anytime we use this nice feature of C# language, C# is emitting given code. It creates an async task method builder, which creates a synchronous state machine, which takes care of parameters, context switching, and all of different things. So we use very nice syntax, but behind the scenes, a lot of weird different things are happening. And in our case, we simply don't need it because this is the scenario that I was talking about. So if we want to consume value task, we just call the method, check if it was completed, and if it was, yeah, we just take the result, and this is fully synchronous, and it can be inlined totally. And as a plan B, we switch to the old way, we just await the task. So of course, I have more benchmarks. This benchmark is measuring just the overhead. So the case is we have 100 synchronous executions. So the result is always ready. So it's just returning task result from and value task from result. So if we use the task, as you can see, we allocate managed memory. And the goal for .NET Core and ASP.NET Core is not to be fast. It's to be as fast as possible. This is why Microsoft is taking care of all these edge cases. So we don't want to allocate managed memory in high-performance scenario. We don't want to introduce the GC. But if we do it in the wrong way with value task, with just async awaiting, as you can see, we also don't allocate the memory, but we are anyway slower than doing the task. But if we do everything properly, we have no allocations and we are faster. This is our goal. So please remember that the goal for value task is not to replace the task, because maybe some of you remember the words of Joe Duffy, the ex-architect from Microsoft, that he said that making a task a reference type was the biggest mistake of task parallel library. But unfortunately, we cannot change it, and value task is not a replacement for task. We use it to solve this single problem. And now another reminder from .NET internals. So in .NET we have small objects and large objects. Anything that is bigger than 85,000 bytes is considered to be large object. So these objects like arrays, strings are allocated on the large object heap, a separate part of the heap. The small objects are allocated in Gen 0. If they survive the first collection, they are being promoted to Gen 1. If they survive another one, they are being promoted to Gen 2. And this model is perfect for scenarios where young objects die young. So think of a web server. You get a web request, and it's stateless. You just go to the database, do something, and come back. All the memory should be deallocated after the request is done. Yes? Yeah. So this model works perfectly. But the objects that are supposed to live for a longer time, like your dependency injection container, all the singletons, the .NET framework itself, they are being supposed to be the long living. And usually the Gen 2 is very big and the cleanup of Gen 2 is very expensive. But the problem with large objects is that they are bound to Gen 2. So anytime you run out of space in large object heap because, for example, you are allocating a lot of large strings, a whole heap is being cleaned up. Gen 0, Gen 1, Gen 2, and large object heap. This is something that we definitely want to avoid in high-performance scenarios. And how can we do that? I would say that there are two ways. Rewrite the GC. And the second, the simplest one, pull the memory. So we have finally a very good implementation of the pull pattern. We can just pull the managed arrays. You can find it in the system buffers package, and the solution is tuned by the best engineers at Microsoft, people like Jan Kota, Steven Dope. So if you are using some custom pull, I encourage you to try to compare the performance with this pull. And one very important thing, the pull has default max size. I will come back to this soon. So, how do we use the pull? First of all, we need to obtain the instance of a pull, and the array pull shares the shared property. It's a thread-safe shared pull that is used by all the most common libraries, like ASP.NET Core, Kestrel, ImageSharp. So, if the default max size is not enough for you, you can just create custom pull by calling the create method. But once you have it, you just rent the memory and you get an array. But the important thing is that we specified the minimum length, so what we get will be bigger than what we have asked for. So if you later on use a for loop with given array, you need to remember that the difference between min length and the length of the array will be some random memory. Once we are done using it, we just return it to the same pool. And if you want, you can clean up the memory, because the return has an overload, and you just specify true as the second argument, and the memory is going to be cleaned up. This is important when you, for example, when your company is running multi-tenant software and you have different customers using the same process. So let's compare it. Is it worth to use the array pool? First scenario, allocating. Second, returning, renting and returning the memory. For small chunks of memory, like 100, we can see that allocating is actually faster. So it's not beneficial. But when we get up to 1000 bytes, we can see that they are on par in terms of performance. But the more memory we want to allocate, the allocator becomes slower because we get more garbage collections. So here we can see that it's beneficial. It's 8 to 9 times faster in that case to just pull the memory. But what happens when we reach this limit of 85,000 bytes? We get Gen 2 collections, as you can see. And this is the very important and expensive thing that we want to avoid. With renting, with just pulling the memory, we don't have this problem. And as you have observed most probably right now, is the fact that for pulling the memory, we have almost constant cost. So we can predict how our code is going to behave. So we can give a very good service layer agreement, like this is guaranteed to be executed in that way. Because as you know, garbage collector is a heuristic, so you cannot predict 100% cases how it's going to behave. Maybe it's going to do full garbage collection when you are transferring or processing some important data. But what happens when we want to pull memory that is bigger than the size of the pool itself? The pool is just allocating the memory. It's not throwing the exception. And if this is a common case, we should avoid that because we wanted to pull the memory. And how can we find out if it's a problem with our application? So we have a new namespace in ETW events. It's system buffers, array pool event source, and we can use some of the existing profilers like purview to just watch for this event, buffer allocated. This event means that you wanted to rent the memory, but we allocated you the memory because it was bigger than the pool itself. So if this event is common in your application, you should most probably create a custom pool. So please remember that this large arrays, large strings are large objects. They are being allocated on separate part of the heap. And if you run out of memory there, you have full garbage collection, and it's very expensive in terms of time. And array pool is really simple to use and super fast, and it has constant cost for working. And please don't create too many custom pools, because our goal was to keep the large object heap small. If you create 10 custom pools, you end up once again with the same problem. All of the popular libraries are using only the shared property, only the shared pool. Okay, who has ever used Stackalog? Okay, one person. Who has ever complained about the performance of .NET? More people, okay. So, Stackalog is the fastest way of allocating memory in .NET. It allows us to allocate memory directly on the stack, not on the heap. As you can see, for small chunks of memory, it's even 2 times faster. But let's take a look and compare all different types of memory very fast way. So as you know, we have small objects and large objects, the managed memory. The allocation is fast, but the allocation, as we can see in the movie, it's blocking. GC is suspending all the threads for majority of the part of the job that it's doing. But once we have the memory, it's very easy to use because we know all of the IEnumerable extensions, yes? So when was the last time that you have to implement any new extensions for IEnumerable? Yeah, it's very easy to use and very convenient and very safe. On the other hand, when we allocate memory with Stackalog or Marshall, we have very fast allocation and very fast deallocation. Marshall is a separate API that allows us to allocate memory on the unmanaged heap, like in the C++ way. But we end up with a pointer. And when have you seen a public API in C# that was accepting pointers? Most probably very long time ago or never. And as I said previously, working with pointers is unsafe. So let's now try to answer the question why the APIs that accept pointers are not so popular. So let's try to design an API for parsing numbers. So first of all, we take a string. Yeah. What if we want a part of this string? So then we need to have another overload. We need to take the start index and the length. Okay. And what if we want to handle strings that are bigger than 2 gigabytes? We need another overload that accepts longs. Okay, this is managed memory. What if we want to handle unmanaged memory? We accept pointer and the length. And what if part of it? We accept 3 arguments. So as you can see, to support any kind of memory, we came up with 5 methods. And I believe that this is one of the reasons why the unsafe methods in C# are not so popular amongst library developers. But span is the new type, super powerful, that is going to solve this problem. So it allows us to work with any type of memory. It's an abstraction. It allows us to work with part of an array or an array, with stack allocated memory, with memory allocated on the unmanaged heap. It's fully type and memory safe, so we don't have the C++ nightmares. And it has almost no overhead because internally it does very simple pointer arithmetics. And moreover, of course, it's a value type. And as you know, from today, it's a read-only value type. But it's also a stack-only value type, which I will be talking about soon. So how do we work with span? We can allocate memory directly on the stack alloc in safe context with C# 7.2 and create span out of it. We can allocate memory on the unmanaged heap, get the pointer, create span. For arrays, we have even implicit cast operator, because this is the most popular use case. And as you know, strings in .NET are immutable. So to respect that, we have read-only span, which just allows us to read the memory. And the API of span is super simple. I would say that we can think of it like of an array, because it has the length indexer, which allows us to get and set the values. Moreover, it allows us to do slicing and clearing the whole memory or filling with any value. We can also copy it somewhere, and if you want to pin this in memory, there is a method with a very nice name. Currently, the CoreFX team, CoreCLR team, and Roslyn team are arguing about this method because the guys from Roslyn team don't want to make it a part of C# language. So it might disappear. At least I hope so. So how is our parsing API going to look like with span? Whatever it is. It's some memory. We just access the values, we use the length. This is why now using the unmanaged memory is going to be much easier in .NET. And what if we want to copy memory somewhere? We just accept 2 spans. So if you take a look at system buffers package, you can see that buffer.copy method has 8 overloads, just to solve the problems that I was talking about. With span, it's much simpler. Another good news is that span works for the existing runtimes. So we have span that contains of 3 fields. Let's say that you want to create span out of a second half of the string. The pointer will point to the beginning of the string, the offset will be the number of elements to the middle, and the length will be the number of elements to the end. But with the new runtimes, these 2 fields were merged. Because for the existing runtimes, we couldn't merge them because garbage collector would have no idea how to update a merged pointer. So .NET Core 2.0 has a native support for span. And if you take a look at some book from Rust, which is a high-performance language, you can see that the implementation of type called slice is exactly the same. 2 simple fields, pointer and the length. But some of the people call these 2 versions of span the slow and the fast one. So I have some more benchmarks for you, and I have compared the speed of indexer because I believe this is the most important part of span because we will be all the time reading memory and writing memory. So as you can see, I have measured .NET 4.6, Core 1.1, and Core 2. And the difference is from 12 to 14%. So I would say that it means that the slow span is not that slow. And you don't need to worry about this if you would like to use span with existing runtimes. But as pointed to me by Krzysztof Cwalina from Microsoft, there is a place for further improvement. So in the future, the guys from JIT team might introduce some magic tricks, and the fast span will be much faster. Maybe not much, because there is a small gap. Because span was supposed to be as fast as the RI, and you need to know that the RI in .NET is as fast as RI in C++. So for the new runtimes, this goal was met. So span is as fast as the RI, but for the existing runtimes, it wasn't. Because we have these free fields and it has some extra overhead. And why it's not going to change? Because if we would like to tune it, we would have to release a patch for Windows. Because if you want to change something in desktop.NET, you have to change it and then release a patch. And then people would have to install the update. And let's not lie, people are not likely to installing updates. So this is not going to happen for the existing runtimes. So, and now another super important thing, how substring works in .NET. So we just want a part of a string. What .NET does is allocates new part of memory and copies what we wanted to this memory. So it's expensive. With slice, with span, we just do the slicing. So we just calculate a different pointer. We just operate with the pointer. So as you can see, two simple arithmetic operations. We don't copy any memory, we don't allocate any memory. This is why when we compare substring with slicing, we can see huge difference. For a string of 10 characters, you can see that substring was 4.5 times slower. For bigger strings like 1,000 of elements, it was 47 times slower. So it's a huge difference. And with slicing, we once again have a constant cost and zero allocations. This is why span and slicing has a huge chance to get into all of these APIs, especially the ones that are used in a web request flow. Because if you take a look at the web request, you see that we start with a stream of bytes, then we read the headers, then we start some decompression, formatting, and stuff like this. So previously, everywhere, .NET was allocating memory because it was doing substring internally, and now span is being used. And one important thing, not all of these APIs are finished as of today. If you would like to start to contribute to .NET, to change the future versions of .NET, you can contribute to CoreFixLab repository. You can find it under the github.com/.NET/CoreFixLab. And this is a repository for experimental things that if they are a success, they're being moved to CoreFix, which means the MS Core Lib, the basic class library. So I believe that this is for us, non-Microsofties, a chance to change the future version of .NET in a real way, the good one. But if we think for it for a while, span can contain pointer to the stack, yes? And as you know, when a method starts, we get stack, and when the method ends, the stack is being unwinded. So everything that was allocated on the stack is gone. And this is why span is first stack-only type in .NET. So what does it mean? Span can live only on stacks. And it has some advantages. First of all, stacks are short-lived, so GC will always have very few pointers to track, because the method ends, boom, span is gone. Second of all, stacks are not shared. Only the thread that owns the stack can touch this memory. So we don't need ever to synchronize anything with span. So we have super good performance and safe concurrency. but it comes with a long list of limitations. So, first of all, if we can store something only on the stack, it means that we cannot go to the heap. So, let's analyze this example. We have a method that accepts something which implements IEnumerable of t. And now, what if we send a value type that implements this interface to that method? So this is what Dina was showing today. We get boxing. And this is why span is not implementing any interface like IEnumerable. So you don't have IEnumerable extensions for span. And because of this limitation that somebody could, by mistake, by accident, allocate span on the heap, it's not going to implement any existing interfaces. Second of all, as I told you with the async state machine, which is being built by async await, at some point of time, the parameters might get stored on the heap. So span cannot be a parameter in an asynchronous method. Moreover, it of course cannot be filled in a class, because classes are being stored on the heap only, at least as of today. And it also cannot be a generic argument in a generic constraint. But we have another type, which is supposed to solve these problems. So I would say that memory, it's a very fresh idea, but it already got to system memory package and is already used by the alpha version of SignalR. So a memory is something like span, but it cannot be created for the stack-only memory. So you cannot create it from an array. So it doesn't follow all the limitations that span has. So, and it works in a way that, for example, you would like to use some method in asynchronous memory. So you create a memory from a table, you send it to asynchronous method, and in this implementation of the method, once you really want to touch the memory, you just call the span indexer, and it creates span on demand for you. And then you work with that. Another new type is owned memory. So in some cases, you would like to control the lifetime of memory or pin it. So pinning is of course the simple case, but releasing and retaining is something else. So in some scenarios, you might be sending given memory to different threads, and one of them may say, hey, I'm using this memory now, please don't release it, don't dispose it. So this is the type called owned memory. And the very, very good news is that in .NET Standard 2.1, we have a lot of new methods for the existing types that are consuming span, memory, read-only memory, and all of the new types that I've been talking today. So if you target .NET Standard 2.1, which will be released, I'm not sure if, maybe at the beginning of the next year, all of these types have new methods that are accepting span. So in some cases previously, for example, if you wanted to get a byte representation of GUID because you wanted to save it to database, you always had to allocate, because GUID had the method that was allocating the managed array and returning to the array. Now you can allocate span on stack, send it to the GUID method, and it will just copy the representation to stack allocated memory. So you avoid allocation. So span makes it easy to work with any kind of memory. It's safe, it's fast, but it comes with a long list of limitations. But to overcome the limitations, we have this few extra types: memory, read-only memory, and owned memory. Okay, have any of you ever write code in IL? Not in C#? Okay, so to tell the long story short, because I'm running out of time. C# and F# are compiled to IL, its intermediate language. But what C# and F# offer is just a subset of things that that the IL can do. For example, sizeof. In C# you can use sizeof only for the primitive types, like int, char. If you have a custom value type, you get compilation error. But in general, IL offers that. Just the guys from C# decided to not allow us to use it. So previously, some of the people used to write IL to overcome some of the C# limitations. Now all of the most popular methods were put to this class, which is available in this NuGet package. So if it was the case for you previously, now it was all put to single place. And I know that not every one of us has the chance to work with .NET Core, but the good thing is that all of the things that I've been talking about today support .NET Standard, very low one. So if you have latest Rider or latest Visual Studio, you can use all of these things in your existing desktop .NET applications because they support .NET Standard. And to sum up my entire presentation, please give a chance to value types. I would rather change the way of thinking, like not why it should be value type, why it shouldn't be value type. So for example, I by default make everything a structure. And when the problem comes, I change it. The next thing, we can use managed references to get rid of unsafe, get performance that can compete with C++. The value task, I would say that unfortunately the usage of it is very limited, this single scenario. But my point was to explain to you how it works, because I have seen a lot of people using it blindly and thinking that it's a replacement for a task. RI-pool is a really nice thing that allows us to work with pooling. Very smart, very simple idea, super huge performance benefits, and it's easy to replace allocating RIs with pooling the RIs, if you can control the lifetime. And span is a great thing for working with any type of memory, and slicing is the way to get rid of allocations. And we will see span coming to all of the types that we know, to string, to GUID, to int. All of the parsing formatting that used to be done with allocations now will be optionally done without any allocations. But if the all limitations of span are a problem for you, then please just use the memory or owned memory types to overcome these limitations. Here is the list of sources. So, few very good things. A blog from Vladimir Sadov. If you like C#, this is the best place to follow the news about all of the changes. A span design document. This is the document written by the guys that actually designed span, so it's also good. And here are a few issues. If you would like to find out more about the things that I've been talking about now, because everything is open source now in .NET, you can follow the discussions and learn not only how the public APIs looks like, but what was the process of getting there. And now is the time for the questions. Yeah.
All right, thank you very much, Adam. Let's start with the questions again, one from this part, the other from the other one. I think that was the first hand I saw.
Yeah, thank you indeed. I have a question, like maybe technical questions regarding the array pool. So they are generic, right? Which
Yes.
makes sense because like you need concrete type. So if you make an array list of bytes and an array list of ints, for example, these are two types, in fact.
Yes.
And do they, behind the scenes, still share the same memory, or do they pre-allocate the same amount of memory for ints, for bytes, for chars, for whatever else?
Yes. They allocate a pool per every type. And to avoid the synchronization, we have, in reality, we have small pools per every physical core. So if you take a look at the core CLR and the implementation of the pool, I believe it's really great code to read, because to overcome the problem of having the synchronization, we have very small pools per processors. But as you said, if we do it for multiple types, we get multiple pools. This is why we should really try to use the shared property to not multiply the problem. Thank you. Okay.
Thanks a lot for the presentation. I just want to make a small note that Stackalog maybe is not the best way, not the fastest way of allocating memory, because it should fill all memory by nulls and so on. So,
Yeah, but managed allocator does the same.
yes, but if you use already allocated memory and just get already some kind of prepared pointer for already allocated memory, this is a faster, but you are not sure that it's free. But in some cases, you don't need to fill the memory by nulls. You said, just give me the pointer and I will fill it by my own data. In some cases, it's really has a difference. In some cases, it's even used. Maybe, you know, the sharpdx library, in some cases, this is some kind of a bottleneck. And in the previous version, that was in a production. So my question is how deeply spans introduced in the JIT compiler? I mean, do spans have so nice features like elimination of bounds checking and so on? Because for arrays, it's a really great feature for them.
Yes. So thanks for pointing this out. And they have native support. In January and February, the team for improving the generated assembly code quality was working on this. And they already have the bound checks eliminations and few other features. And this is why span is as fast as the RI for the new runtimes. But I know that they have some more ideas, even more than for the RI. But they just don't have time as of now for the implementation.
Great. Next question.
Consider the case that we allocated memory via array pool, and somehow developer forgot to release it, or application failed. I don't know. Do we get memory leak here?
When you rent the memory, you get the RI, but nobody else has the reference to this RI. So if you forget to return it to the pool, garbage collector will simply release this memory. And the problem that because there will be no references to this memory. Because pool is not tracking the RIs once you run them to be faster. So you will get to the point where your pool is empty. And honestly, I'm not sure if it's going to allocate new RI for you or throw, but I am going to check this. Most probably it will allocate, but I can check this.
All right. Other questions? We have some time because the other truck is a bit late because of technical problems. There it is.
Okay. Great session. You mentioned contributing to the GitHub to core effects. And usually in
Can you speak
GitHub,
a bit louder, closer to the mic?
Okay. You mentioned contributing to the GitHub project, core effects. So
Yes.
normally in GitHub repositories, there's a app for grabs issues that so if somebody wants to start contributing to some library or repository, you can start with those. Are there something similar in core effects? How can I start contribute in such a library that a lot of the discussion is not in front of me or I don't know about?
Yeah. So the repositories that are open for contributors, they follow this guideline of marking the issues as up for grabs, as you said. But I believe that in both Core CLR, Core Fix, and Core Fix Lab, you will find plenty of them. But I would say that contributing to Core Fix itself as a first repository might be hard, because they have to take care of the backward compatibility, and they are not very open to adding a lot of new methods to the API, because they try to keep it small to make sure that everything works correctly all the time, and so we can trust it. So I would say that most of the up for grabs issues in CoreFix, I hope that nobody is going to kill me for this, are some tough bugs. So you will just rather have to debug for many, many hours, and maybe you will end up with small fixes. But on the other hand, CoreFX Lab is open to designing new things. So you can come up with your idea and develop it. Because the API is not sealed, it's not public yet, it's not released. So this is why I encourage people to contribute to CoreFX Lab, because it's more open for new ideas and changes.
Okay. Thank you.
Thank you.
Hello, thank you for the presentation. I believe your game can be improved by switching on GC server feature in runtime. Did you try it? The time gap.
But which features of the runtime do you mean exactly?
No, by default, the GC server is disabled, and all modern CPUs are multi-core, and if you enable this feature, the time in GC will decrease for 1% from, no, if the big pressure in GC, this feature can decrease this timing.
Yeah. So the feature of server mode, it's disabled by default in .NET, but every application that is hosted by IIS has this feature enabled by default. And you have to choose it wisely if it should be disabled or enabled. For example, if you have 100 microservices on your machine and you have 8 cores and all of the applications are going to run in server mode, then each of them is going to have 8.8 times 2 threads. So 16 for 100 microservices, so you are going to end up with 1,600. So this is why you should choose very wisely if you have a lot of applications running on the same server to turn on or off the server mode to not get into the situations when you have just too many threads with high priority running for GC, and because they will just starve.
Okay, thank you. But you agree that it's worth to experiment with it?
Yes, and if you would like to experiment with some concrete scenario, in benchmark.net you can write single benchmark for different configurations of GC. You can say, I want to try this code for server mode, for workstation mode. Okay.
Do we have other questions from this part? No? Okay, so move in here.
So I have the simple question. I have seen the results of tests, performance tests, and is source code published for these tests, and where I can find it if it is.
Okay, so github.com/my name and last name /state of the .NET performance. And this repository is more than 1 year old. When a new feature appears, usually people from .NET team create bugs in benchmark.net because something doesn't work. So I implement the support and then I update the benchmarks. So you can count on it that it's almost always up to date.
Thanks.
All right, so we have time for one more quick question if we have it. Anybody?
Thank you for the talk. I have some problems with stack-locked memory later when I used it. Generally, I couldn't pass it to some other methods because I allocated memory on stack. Will I be able to pass stack-locked memory that wrapped in span to other methods or no?
These safety rules are being implemented right now by Vladimir Sadov. And as far as I know, you will be able to send it to the synchronous method that doesn't last longer than your current method.
Okay.
So there will be new rules enforced by C# 7.2.
All right, so let's give a warm round of applause for Adam and thank him and say Dzakui.
Thank you very much.
And,